What do you reckon the chances of that are?
Right, so the first thing, I'm going to get these switches together. Because otherwise I just...
And what you see here is a piece of equipment for 10 gigahertz, which is capable of sending signals to the moon and back. And in order to keep it pointing at the moon, we have various pieces of equipment. First of all, azimuth is adjusted this ring. Elevation is adjusted here. We have an inclinometer that measures elevation and azimuth around the ring. And if perchance the moon was visible, we could actually look through this rifle scope and very accurately point at the moon, but it doesn't look like it's going to be visible today. The other thing we do is we line up the moon or the sun and peak it on sun noise such that this telescope is pointing exactly at the sun with a little bit of paper that goes across the top of that. The equipment itself, there's a preamplifier here, transverter down here, and a 50 watt PA which is over here, which doesn't quite do 50 watts but gets pretty close, and a large heatsink with fans. Now all of that feeds down these cables inside the room, where we've got essentially a 144 meg setup. We'll transfer it down to 144, and we're going to use the mode called JT4F. Now JT4F, people wouldn't generally be familiar with it. Most of you are familiar with JT65C on 2 meters and 432. The problem is when you get to these sort of frequencies, the bin width of JT65B, for instance, is only 4.8 Hertz. And when you get to these frequencies, you get Doppler shift, differential Doppler from both sides of the moon, which spreads the signal out. Sometimes as much as several hundred Hertz. And obviously you can't use bin widths of 4.8 Hertz if the signals spread several hundred Hertz. So Joe Taylor, who wrote the WSJT suite, developed this mode called JT4, which we have been able to develop further in conjunction with Joe. I mean, we just keep giving him hints and challenges and he improves it. And the way the mode now works is it actually starts with a narrower bin width and tries to decode your signal and thinks, no, didn't do that. Then it doubles it, and then doubles it, and then doubles it again. until it ultimately matches the bin width to the spreading off the moon, and you get a decode. And with that technique, we're able to use digital modes up into the microwave frequencies. There are a couple of other little tricks we use. Because the Doppler, we're not talking about the differential Doppler, we're talking about the absolute Doppler, which is mainly a function of us moving on the Earth, you know, because when the moon's rising up there, we're actually going that way. We're moving away from it, and that's causing a lot of Doppler. There's also the Doppler of the moon's movement, but that's secondary because the moon only goes around once every month, whereas we go around once a day. In order to correct for that Doppler, what I've got is a little program that works out what the Doppler is and keeps tuning my IC910 to perfectly correct for it. Now I've done some tests with a guy in Russia on it, and that was down on lower frequencies, like 2.3 gigs, and it stayed within 2 Hertz for 4 hours. And on 10 gigs, sometimes it's 10 kilohertz out, isn't it? 10 Hertz out, isn't it, Alan?
Not much.
But not much. On 24 gigs, it sometimes gets 30 Hertz out. But, you know, and it's perfectly tracking all the time. Now that little program was written by Glenn English, VK1XX. See, I actually don't do anything, I just encourage other people to do things. And then I put the bits together. That was my job once. Encourage other people to do interesting things. So, in order to get these narrowband signals off the moon, we're going to first of all correct for all the Doppler. We're going to have a mode that can take account of the differential Doppler. We also need a reasonably big station at the other end, because this is not a big dish. This is only a little portable dish. So the other guy at the other end, he's going to be running a 5-metre dish. I can work people with less than that. Alan has got a 3-metre dish. We have plenty to spare. Alan runs 75 watts, and typically on JT4 his signals will get down to about minus 13 dB, which is a fairly strong signal. You just hear they're there, you can't actually detect any CW. You and I can't. But I guess the key to all this is lots of things have had to be developed and got right. Being able to point accurately, being able to get the Doppler done accurately, getting your partner to turn up accurately, which is a bit doubtful in this case, but normally on 10 gigs I work with David and always turns up. But
Mostly, yeah.
Mostly, yeah. I mean, it's a real pain. You go 200 kilometres out, try and set up a skit and someone doesn't turn up. That basically is it. To complete the QSO, one of the techniques we use is, because we're very accurately corrected for the Doppler, normally on WSJT you send 2 tones for ROs or RRRs and 73s, and they're spaced separately apart. And the spacing tells you whether you're getting that final confirmation. But because we know we're exactly on frequency and we've corrected for it, we don't need to send 2 tones. We can send a single tone spaced different parts from where we expect to see it. And that puts 3 dB more energy in. And I better start going to look to see whether he's there. Okay, thank you. That was a bit longer than it was supposed to be.
What are you focusing on?
I need to repair.
I like his tripod. Bloody beauty. Marvel.
Receiving him. There's probably
the fans on? Yeah, really could come in handy. Fans are on.
Are we clear of the trees?
Oh, Not
really.
quite.
You've got the azimuth and elevation set?
Yeah.
Quite, just in the towards the upper reaches of it.
So probably a bit of signal a bit.
Yeah.
Am I allowed to ask
Half a tree.
what you blokes are doing? Hey, because I'm a neighbour here and I didn't want to be zapped in the backyard. That's all.
The moon's
yeah.
through those clouds somewhere.
I see.
So we're going to try and receive a radio signal off the moon.
Bounce it off.
Yep.
Oh yeah, I see.
There's
That's,
a gentleman over in Texas was waiting for our signal now.
oh, that's great. No, I wondered. I meant to ask last time you people were here, and I thought, now you've got more equipment this time. But it's got really serious, has it?
Well, we've had a year to make it a bit more serious.
Well, that's great. That's great. No, this is great.
Usually hear something of him. You probably wouldn't.
You can just hear the tone.
Yeah.
It's a nice full angle.
Yeah. Well, I mean, yeah,
On his compressed signal sense.
yeah, that's the signal strength is not. Oh, Reed's having a look for him. Okay. 3GHZ.
Possible for you though to have the system set up so you can look for a return signal from the moon, just a reflection back.
Yeah, but with my dish being so small, it's too weak for me. I can see it when the moon absolutely stops vibrating, wobbling.
Okay.
But I've only ever done it once. My dish is too small because you see, my dish is about 10 dB less than his, and I'm losing 10 dB there and 10 dB back, so that puts me.
So if you wanted a 3 meter dish actually, though, would you have a very chance?
Oh yeah, absolutely. Yes.
So your test signals, how long you send the transmissions for? It sounds like maybe 30 seconds.
A minute.
At least a minute, really.
Well, 46 seconds, but it repeats every minute.
So the guys at the other end are using that 30 seconds to actually hear, try to receive your signals over that 60 seconds.
Yeah. Okay, well he sent me R-17, so I can send him RRR, which is a 1500 Hertz tone. So he's actually received me a bit weaker than I've received him. That could be just the luck of the draw. Or
What's his power?
What's the same power?
Oh, same power.
He's only got 50 watts, but because he's got a bigger dish, he sees more moon noise than me. Because the moon noise is only a small proportion of my dish size. Because my beam width is 3 degrees and the moon's only half a degree. So I don't see much moon noise at all, whereas his dish is totally focused on the moon.
Yeah.
What's the level of attenuation of the clouds?
Not that much on 10 gigs, 1 or 2 dB, but on 24 they kill you. You might as well not try.
Especially the dark ones.
Full of water.
Battery's gone flat, Peter.
I've got back up.
I got a couple.
Now you see, he was sending messages and he swapped over and he's sending 73.
Single tone.
Single tone, 73. And you can see how much stronger that looks.
That's exactly what he's doing.
What's your best angle? Is it better as you get higher, Rex, or?
Not much.
Depends on the closer the distance.
Yeah, at
as well as
24
the
gigs,
Yeah.
it matters because you get much less absorption through the water
Yeah,
vapor
of
at
course.
high angles.
What about noise-wise? Is it higher than
Oh, the
than
beam
5?
is so narrow that
Yeah.
once you get above the trees, you're clear of them.
Yeah, right.
Okay, he's giving Roger to VK3ER,
It's copying that the last.
and it's a nice strong signal.
I
called Jake on 1296 in my day.
Okay. Who wants to have a contact?
Call someone in there, Rex, I can then say I've had a...
Yeah. Well, you've got to bloody put it in yourself.
Oh, do I?
Or York USA.
Does he move down?
Set up.
Does he move on the breaking next?
It's a good nose. Computer nerds and the RFS.
Okay. Go out of that, and then we just click this, and that's your call sign, correct? Calling him. So we put that there, and now you're calling him, and when he comes back, you'll come down to one of these, depending on which approach he probably wouldn't have got enough signal that time to have responded, so we probably have to wait for the next time because we changed it in midstream.
Oh, because you moved it. Why do you say that? Maybe I've got enough signal.
Oh, because we changed it while we were still transmitting. So we transmitted 73 for most of the period, and only about the last 10 seconds did we transmit the message.
Oh, gotcha. Okay.
So, well, it'll be interesting. He's calling somebody. Maybe he'll just call CQ. I don't know. It'd be interesting.
There's other guys around too, and there's other people.
Well, most of them are in Europe, so they won't have to move.
Right.
They're just watching.
So this is really... Oh, they're just watching on there.
Yeah.
Oh, right.
Yeah. CQ. Okay. Well, you'll just call again.
I just called again. Is it? It's doing it, is it?
Yes.
Oh.
Yes. You. That's you. Is it?
Right. Yeah, that's me. Yeah.
Yep. Yep. You're calling. The yellow means that's what you're seeing.
So, so this knows when he stops transmitting.
It does it on 2-minute cycles. So it transmits. We transmit for a minute, and he transmits for a minute.
That's a fixed.
That's
cycle.
fixed. And the most easterly station always transmits in even minutes.
Gotcha.
Yeah. And we're west of him.
So it's just a time.
Yeah.
It's not a squirrel space thing.
Yeah, if we wanted to transmit first, we would tick that to transmit in the first period, but because we're west of him, we transmit second.
New call sign's M7MO, isn't it?
Yes.
Yeah, good. Clint Jeffrey did go through CSJ.
Okay, Clint.
Yeah,
Yes.
I think I've sent you an email once and just passed it out. Listen, you definitely said to me, Clint, get on, it's exciting stuff. So we're slowly getting there.
Okay. Yeah.
But so many other
I'll
projects
just
on the
stay
go.
there. We'll give you some guidance. Hopefully he's going to come back to you. Something's going. Have our dish controllers bloody gone to sleep?
Yeah, no, I just popped out there.
I think they were having sausages.
No, they were doing the right job.
Okay. Yes. Yeah.